make sure that I see what you are seeing. So this presentation is gonna be all over the place, but in general, it's gonna be how we made our last Amiga demo. But let's start from the beginning. The title is Overengineering Amiga Demo Tools. I'm Kiero of Madwizards. So I've been doing Amiga demos since like 99, 2000s. We ended our Amiga story around 2017, and the demo that I'm gonna be showing is from that year. I've been a member of Appendix, Madwizards, Elude, probably some other smaller groups which I forgot or are not worth mentioning, but yeah, that's general gist. So yeah, this is not gonna be showing how we did the effects, how we did the demo in general, but it's gonna be about the tools that we did. And we had like high hopes how to change the process of making this demo, because we were kind of burned out from the previous ones, and we wanted to reinvent the process a bit. So yeah. So as I said, we wanted to reinvent the process, and we had few main pain points while making a demo. So the pain points involved the coding, general synchronization. So like you have the effects, but you want to present them on the screen, right? And yeah, how do you do it in the least amount of time and under the most amount of pressure? Basically, like a few hours before or few hours after the deadline. So yeah, it's gonna be about the composition and asset processing. So asset processing might sound like very boring topic, but when you are right around the deadline, this is something that you don't really want to spend time on, right? Let me give you like some information about how we coded, how we made the demos in the early days. So we had an effect, right? We wanted to put it together with the music. So everything was done on Amiga. So the compilation was done on Amiga. We basically ran the demo. We waited for 5 minutes. We made some notes. We adjusted the demo and we ran the 5 minutes demo. So you can imagine that it was like super painful, right? It's changed a bit when we moved to emulation, but not super much. It was still like run the demo, maybe fast forward to an effect, but yeah, just change the parameters, right? So with the asset processing, that was a bit easier, but this is like old days still. We had like some scenes, we ran some scripts to convert stuff for 3D. That didn't change much, like during the demo, the making process, right? So we just basically did that in the beginning, and it was fine. For graphics, it was always more complicated, because this is not PC, right? You just don't load the graphics and show it on the screen. You have to basically remap multiple images to the common palette set. You have to generate some shade maps, shades for the effects. So yeah, this was like you got a new graphics, you had to rerun some stuff, and yeah, basically prepare the graphics after the graphician delivered that, right? The synchronization, I kind of already mentioned that the initial part was just rerun stuff after the emulation, after we introduced the emulation, because at some point we moved our development environment to emulated Amiga. It was still Amiga OS, but it was like graphics cards, you could run a demo in a window. We moved to the streamed music. So at least you could fast forward to the to the interesting part. So it cut a little bit of this tedious part. You already could use the UI to adjust some parameters, but no synchronization, no actual synchronization was possible from the demo tool. So yeah, this was basically how we did the synchronization for like 10 years. And I don't know why, maybe it's like masochistic nature of the coders, Amiga coders, but this is how we did synchronization. And this if-else ladder was like, I don't know, maybe 20, 30 statements per effect. And it involves like, if time is between this and this range, move camera from this and this position. Literally, we set cameras, we set parameters from the code. So you can imagine how painful this was. We wanted to fix this, right? We wanted to skip this tedious iteration process, like don't spend 5 minutes just to go and polish the last effect in a demo, right? We wanted to remove the tedious work of asset processing, of the... Basically, this was like the 5 minutes that you had to waste, or like even 30 seconds that you had to waste, but before the deadline, this was critical. And when I'm talking about before the deadline, this was really after the deadline, when the organizers were breathing on your neck, dude, you have to really deliver the demo, right? And one of the ideas I also had is like, yeah, I'm busy fixing the effects, and maybe let's involve the other members of the group in the demo making process. I don't know how many of you were making a demo, and yeah, and you are not a coder, how much you participate in the process, but I really wanted, and I had really huge hopes that other members of the group are gonna help me with, on this last push. So this presentation in general is gonna be like segmented in few like areas on the demo making, and I'm not gonna be talking about synchronization a lot because everyone at that point basically moved to Rocket, some external tool. How we do some parameter tuning. If you had that, yeah, this is nothing that is worth really talking about, right? But the biggest part that I think made a difference is how we changed the whole runtime. So like a few years ago, I talked about how we code demos on Amiga. We basically did it like on a PC. But after that, we kind of realized that we are not exploiting all of the features, or at least maybe even none of the features of Amiga, right? So we wanted to enhance that. So we had like virtualized display, but before that it was just a chunky buffer, like a frame buffer to display effects. We enhanced that with a bit more features that are Amiga specific, like bit plane masking when doing chunky to planar, but not really that much. Audio was obvious. We always went with streamed music, and using tools like Rocket, it didn't strictly require us to have streamed music because you could just pre-render the mod to the stream during the demo making, but we just went with it. That is also not gonna be a big point of this presentation. But one of the bigger changes, and something that was really entertaining to work on, was, maybe let's virtualize the CPU, right? So because we had this native Windows basically framework, the application was running on Windows. It basically was a Windows demo at this point, at the initial point of demo making. But we still wanted to target Amiga, right? So let's try to really work on Amiga side of the demo, like assembly routines, assembly optimizations. So let's virtualize the CPU. And the idea was to basically build in the 64, Motorola emulation into the demo. And run the demo under emulation. So you had a mixture of C code and the assembly. The critical parts were basically assembly, and the assembly parts that were the area that we really wanted to focus on. To have some numbers, to have actual like instruction counts, something that I didn't have to send to people with actual Amiga and have on screen, right? This sounds complicated. And obviously we didn't go with the full-blown emulated demo. We just picked a set of routines. We designed this to not require like a state. When you had a routine, all the inputs for the routine was external. So the C code was always just feeding the state to the routine. The routine was just mangling the pixels, it was just mangling the data and spitting it out. It was not storing anything. To do that, you basically assemble the Amiga assembly. Then you parse the binary. There is not that much in this binary that you have to take care about when you have this set of limitations. It is just looking up the code segment. You do the basic relocation of some like local temporary buffers, and basically you're done. You have the memory address that you have to jump into, and just execute it, right? So for the purpose of emulation, we used the CPU core from Basilisk. This is like Atari, Atari emulator. It is based on WinUAE. I don't remember why we didn't use WinUAE. I think the idea was that it had built in like this glue code around the CPU emulation when you literally could just pass the array with registers and the program count, basically the address. You jumped into it and it was like 10 lines of code. So we went with that, and it was super easy to integrate into the code. I don't know if it's visible. Yeah. So you basically pass the address and the registers, right? The other parts are like the stack, some memory mapping, because the emulation uses like custom memory, but we basically mapped all of the 32-bit address space from PC to Amiga, so you could access all of the buffers that were created on the native side. And because in one like assembly unit you could have multiple routines, we did a bit of like a reflection. So you could look up all of the symbols that were declared as extern. So in the code, it looked like this. So you could look up the routine by name, you set up the registers, and if you notice, we had something like the cycles that was returned, right? But I'm gonna be talking about this later. So, you can ask that, you have the emulation using Big Indian as Amiga architecture, right? But you have all the data that is being fed from the Amiga side. Isn't this gonna be a problem? Actually, we thought that it's gonna be a problem in the beginning, but if you focus on the routines that are basically just setting some pixels and they take very basic lookup tables or some like 8-bit data as the input, it was surprisingly how few places we had to modify on the client side to convert the data before we passed it to like the emulator, right? it was a bit more involved when you had like complex structures. But again, the complex structures were just the arrays of integers, like wide words, right? So we had like very short routines that, yeah, take this buffer. This buffer is like 100 bytes, just big Indian to little Indian, and at the output, if the routine was outputting anything, just move it back. This was happening only in the debug build because, again, this was meant to be just development environment, right? So you didn't care about the performance at this point. Amiga side was still executing native code. We didn't do this emulation run, obviously, or we didn't even execute the native assembly by loading it dynamically on Amiga. It was still static linking in the final build. Or that was the idea when we did it. So, as I mentioned earlier, what you execute this code via the emulation, right? What else can you get out of it? So we had this like cycles, a value that was being returned from the routine. It was not actually cycles, because at the beginning it was meant to be cycles, but it's not so straightforward when you're emulating more advanced architectures. But it still gave you a proxy about how many instructions were being emulated. Like all the conditionals were taken and so on. The thing that we had planned for this, and because you actually can do it if you are using emulation, is that you can hook yourself into the memory subsystem, and you can do like tracking what areas of memory are actually touched. So if you're doing like 060, okay, I'm going too slow and my battery is running too fast. So on 060, you have to take care about the caches and so on. So if you are just touching like 2 bytes every like 20 bytes, yeah, you are doing it wrong, right? So by using emulation, you can actually create like a heat map of the memory accesses, and you can optimize towards that. We had that in the debug build. It was never exposed in the tool. Maybe a wasted opportunity, but this whole demo was a wasted opportunity, a set of wasted opportunities. But there are more bonus points if you do it this way. So yeah, you are loading the Amiga assembly, right? So what stops you from reloading the Amiga assembly each time you basically execute the demo, right? So I had this idea about, maybe let's incorporate the actual hotcode reloading. So you had Amiga assembly, another window. We set up a system that was monitoring the directory. And if it detected the change in the Amiga assembly, it launched, it reassembled the routine, it reparsed, reloaded everything, and after the key press, you had a modified routine, right? Cutting the iteration time basically to 0 seconds. And at the point when you were only working with assembly code, because we had this like demo build, and we also always had a fallback. So you always had like a C routine to do it. But at the last moments of the demo making process, it diverged. It often diverged that you ended up only working with the assembly version because that was the target, and we only kind of had assembly version that was the real one. So I'm gonna try to show you how this worked. This is the tool that did the synchronization. Let me just fast forward to the part that I want to show. And yeah, you can already see how it works, right? So you could just fast forward to any part of the demo. Okay. We have this effect. So yeah, as you can see, this is like just the raw Amiga assembly, right? So let's just hack something pretty quickly. No. Yeah, like, I don't know, 10 to the register that is being written at the beginning. To dito. And I'm gonna, okay, yeah, sorry guys. I thought it would be easier. Okay, you can see the screen. Let me just save the routine and nothing happened. Let me maybe do something a bit more dramatic. Anything changed? I'm not focusing. It did? Okay, yeah, okay. So, sorry, it's nothing like ground breaking or anything, but I hope that you saw that you had like native Amiga code and you could just modify the assembly. You had the immediate change on the screen. So that was like super fun. The most fun that we had with it is that when I got it working, it was not really about the how you work with the effects. It's like pulling off this let's build the emulation in, let's have some like dynamic code reloading. It was we are done, right? So yeah, this was like the biggest one, and I'm gonna talk about what worked and what didn't work later. But this was actually the part that helped us during the demo. So I mentioned the pain points at the beginning, and the second one was how we work with the assets. And while the 3D stuff was simple, the graphics was not that simple. As you are aware, Amiga is like 8-bit. You can do some hacks to do true color rendering, but true color rendering on Amiga is slow and nobody really does it anyway. It was like a thing in maybe before 2000s when people tried to do some really glowy and 200% saturated effects. So yeah, we had like graphics delivered by graphicians who were not Amiga graphicians, really. So they were painting in like 24 bits. They were keeping everything under control to some degree, but the input data was still like true color images. So the most basic step was you have to like reduce the color palette. That is easy. That was easy when you had like effect with some background, some spinning potato in the middle or some clippers. That was easy. But if you had to like create something more advanced like shading, even like textured cube, you had to introduce additional shades to the texture. So if you had like, I don't know, like black and white, only like white texture, you still have to introduce like grayscale to the images. So that started to be a pain when you had like 4 or 5 of these images per effect and some clippers on top, some images in the background. That started to be a pain. We did a lot of this manually. So we had a tool to convert, take this picture and maybe remap it, right? But if you have multiple of them, that is not the way you want to go with the process, right? We introduced a tool that did all of the heavy lifting. You could handle the easy cases, like this is the directory, take all of the images, remap to the single palette, and you are done. But some effects required like additional shades. Some effects required that this is like the overlay, and it's gonna be using like only 32 colors in the upper range of the palette. So let's remap it, reduce, shift the palette, and put the colors while preserving anything below, right? And it could take like multiple images and do all of these weird shenanigans with the images. So yeah, the most simple script was like the one in the top. Disable littering, take all of the images in the directory and remap it, and you are done. But as I said, if you had more of this stuff, you could do it. You could basically like even load the images, and if you liked one of the guys better in the group, you can prioritize the palette of his credit logo more than the palette of the other guys in the same scene. And yeah, we used some color keying. You could do it, but you could do more. You could do downscaling, because even if we had some like 3D modeling guys who knew how Amiga worked, they didn't often realize how the textures are gonna look on the model. So we did some downscaling, we did some color correction. You could really do some weird shit with this tool.
Out of curiosity, the scripting language, you like invented it yourself, right? Yeah, that's me asking. Did you like implement the whole parser yourself to process those comments, or did you use some another
I guess calling it a parser is like a bit too much.
Exaggeration.
These were the days. I'm gonna show. Okay, maybe you saw the tool already when I was showing it. I'm gonna show it at the end how the general application looked. It was 7 years ago. But that's not really an excuse, right? 7 years ago, it was. We could do better. We could do better, but the tool basically started as the 3 lines that you see at the top, and then you are just building some features on top of it. So it was not designed from the start to be this general. But yeah, it ended up saving us tons of time. So if you are doing Amiga demos and you still don't have it, even if your graphicians are like designing the graphics especially for Amiga, not all of the graphics are gonna be full screen images. Not all of the graphics are gonna be like I don't know, some clip arts or something. You have tons of graphics that are used like textures as I don't know, some random shit wrapped around the objects. And having something like this, especially having something like this together with like graphics which is designed especially for Amiga. So imagine that you have like the main picture that you want to show, right? And you want to show some spinning cube with some environment map on top of it. You still have to remap the environment map to the palette of the main picture, right? And you don't want to sacrifice the main picture. You can do it with the prioritization and all of these weird things, right? So yeah, the pipeline, I'm not gonna talk about the internals that much, but you can already imagine how it worked. For each effect, it basically loaded all of the images. It built some global color histogram. It started to populate the histogram with some additional shades. We had some weird shading modes, not only like darken or lighter, we had some weird blending modes. So you throw all of these colors into the histogram. As I said, prioritize, remap, deter if anything. And if you want to use something that we did, there is a library under the link that we used for the actual remapping, like the final pass. I don't know if this is the best, like state of the art at this point. It was pretty good at the time we were developing. And the guys who were on like Amiga, in the Amiga community, Kornel Lesiński is like Pornel from old Amiga forums. So yeah, Amiga roots. So again, as with the code, you also have some bonus points with the process. So we did have like hot code reloading. Yeah. So we had like directory being monitored. Why not reuse the same concept for graphics? So when you had Amiga, when you had the demo running, right, and you reconverted the graphics, we had some hooks for this directory being plugged in. And when you reconverted the graphics, you could see the result immediately on the screen. This is not super obvious because this is not that common case that you just directly load the graphics as is, right? You do some additional processing. So we built the demo that basically per effect, we had a directory with the data, and all of the initialization process was happening in a separated routine. So basically the demo, if anything changed in the directory, the whole demo part was being reloaded. It is easy to build when you design around it from the start. It is hard to kind of pull off as an afterthought, but yeah, we had all of the framework done before we actually started to make a demo, so it was easy to structure everything like this. So, okay, you have code, you have assets, and now what do you do about the actual effects, like the rendering part? So this was something I wanted to really fix in our process and move at least part of the demo making to the other members of the team. It didn't work at all. It doesn't work to this day, but yeah, you can hope. So the idea was to create something like a layer-based system. If you watch like Amiga demos, maybe not like old school Amiga demos, like A500 demos, but if you watch like 060 demos, AGA demos, the usual composition is like you have a background, you have some spinning potato in the middle, and maybe you have some overlays. This is something that is contributing to like 80% of the demo. So yeah, let's try to maybe automate it. Let's maybe build a tool to have something that is gonna make it really easy, right? But we wanted to do a bit more. We wanted to have something that is gonna involve post-processing. We wanted to do something that is gonna have more complex stuff. Even if it looked like you only have like effect in a background, it was the effect that was like built from multiple parts. Like even you have like a spinning object, let's add some glow to it, let's add some distortions, let's add some other stuff. So you already saw it, but this is like the main window that was that came out of it. It is not your like Unreal Engine node-based system or anything, because this is still Amiga. We built everything to work on Amiga that was the idea. So it is very like basic. You have some common flow of like, clear the background, show some picture as the background, show some effect. And yeah, this was the outcome. Could be better, worked fine. It was the only demo that we used it for, so yeah. Okay, let's maybe talk about the more complex effects, right? So as I said, you have some effect in the background, right? You want to add a glow to it, and you still want to show some overlay, like proper picture on top of it. So you have to segment your palette at least to some point. So yeah, let's maybe split it into some ranges, right? because of the I didn't show you the I didn't show you the demo that we actually did. So maybe let's fix this, because I'm gonna be talking about the aesthetics that we picked for it. And yeah, this is the demo that I'm actually talking about. So as you can see, like basically monochrome backgrounds, some actual pictures on top, but you can already see the separation, right? Again, like monochrome picture with some like post-processing added to it. Yeah. So we built all of the tools around this concept. How we. Okay, I'm gonna break my neck. So yeah, we basically built all of this around the style of the effects that we wanted to pull off, right? And that allowed us to actually do all of it. So most of the effects were were split into this like bit planes when you had 5 bit planes dedicated to the effect and just 3 bit planes to some overlays and so on. So when you were rendering the effect and you still wanted to apply some glow to it, you actually had to compress the palette to all of this small range. And yeah, then apply and before, you actually render the effect, you apply the post-processing, but before compositing with the clippers, with the images, you had to compress the range of the actual effect to the meaningful range. You can think that having like maybe 8 shades for the glow and other stuff is not a lot, but with the noise you can, and with the low resolution you can do some really crazy stuff. Okay, I already talked about this a bit, but so I'm not gonna push it. So you had like the background layer and the graphics layer, right? We didn't want the graphics to drive the colors, to drive everything that is happening underneath by the color scheme. So we actually built a UI to allow the artist was meant to do it, but I was doing that in the end because the artists are lazy fuckers. So we actually had this very basic color scheme creation tool when you could build some gradients and tune it to the graphics that were being shown above it. So this is basically it, but the outcome was that the demo didn't run on Amiga. So at the actual party, we tried. I really tried. We had some problems, but because the demo didn't want to run on Amiga and everything was still working as a PC demo, native PC demo, we released it as a PC demo. So you can think that all of that I was talking about was a failure, right? But no, it was just the most stupid thing. It was the music, music playback part. And the saddest part is that this was the part that we reused from the previous demos. It wasn't supposed to change. It was supposed to be the code that I don't have to worry about and just flip the switch and it would just run, but it didn't. So as a last resort, we actually won the PC demo competition, if I remember correctly. but it is still available as a Amiga binary on Poet. So the biggest gain we we had out of it was actually moving from like the native or like emulated Amiga environment to the Windows system. If you don't crash or if you don't have to reset up your environment, it is gonna save you so much time that it's really hard to explain. I was like a hardcore Amiga user, so we really tried to do everything on Amiga. But yeah, the stability of the environment is not the strong point of native like Amiga environments. So really, that was the biggest part. Not the hot code reloading or anything. That was a nice bonus, and it is kind of an obvious win, right? The second win was actually the compositing part. When you are like pushed against the deadline and you have like missing 20% and you want to throw something in, and you have this UI where you can like, throw this picture, throw this effect, throw this overlay, in like, I don't know, 5 minutes, it's gonna make or break your release. So that was the second biggest part. The palette tweaking when someone is sitting like next to you and you can guide you and actually sees the effect, that was also huge win. With the compositing, there is a bit more to talk about because you can think that Amiga is slow, and if you design all of this compositing system to create this layer-based stuff, it's gonna be slow, and it was slow. It was not super slow, but like 10% or 20% can make or break the demo when you are running around, I don't know, 12 or 13 FPS. So we still had to build like some special cases, like when you have this common path where you have an effect, you compress the palette, apply the glow, and apply these like 3 steps. We still had to detect them when they were like enabled in the UI. So we still had to build special cases in the application to optimize this, because we thought that it's not gonna be costing us that much. But as I said, 10% can be make or break of the demo. But the UI was still the same. It was just me in the background doing the heavy lifting. The part about the emulation and the code hot reloading, as I mentioned, it was kind of a gimmick, and it was nice to pull it off. We thought that it's gonna be too limiting to actually use it in a demo, but no. I actually did like the code search for this project before this party, and we used it in quite a few places. We actually didn't only have like full screen effects using this emulation and hot reloading, but we had like triangular rendering, we had line rendering, and some other effects using this concept. So it was not, it was not a wasted effort, in my opinion. And if you consider that you still want to have some fun making the tools, that was not a wasted effort at all. And about the proxy of the instruction count being used as a performance metric, on 060, it's actually pretty decent metric if you assume that your code is decently optimized. Because most of the instructions are like 1 cycle or half a cycle if you pair the instructions. So if you assume that you optimize the code decently, you can use the instruction count as like a performance metric if you ignore the memory caching and so on. So I didn't have to send so much iterations to Fibrizzo to test the actual performance. So the asset reloading, for assembly it was great. Actually very useful. For graphics, not at all. It depends how much you work with the graphicians, how often they send you the graphics, how often you have to actually run the pipeline. So the batch processing was absolutely a blast, right? Because it is actually hard to do it manually. But if you have like hot reloading of graphics, not really. Maybe for some very simple stuff, but we didn't use it that much. And yeah, I think we are done. And the line that you are seeing is actually when you run the emulator and it either runs out of memory, or like if you stomp some memory or you trash the stack or something. Yeah, this is something that you see quite often. Yeah, that's it. If you have some questions, I will be glad to answer them.
Thank you very much, Kiero. Give him a big round of applause. Woo!
Sorry for being so random.
No, thank you very much. It was a fabulous presentation. Guys, the microphone is here. If anyone has a question. Okay, there is a question from Hakon.
I have a question. Is it usable by anyone but you? Or do you want to release it as at GitHub or anything like that?
I want to. I want to release it.
What stops you?
Time. No, it's not super fun to get the code and get it. I actually thought about releasing the whole project for this demo. It's not super terrible, to be honest, and we still might end up doing this. But yeah, if you are interested and if you actually want to have an access to the code, I think I have it on GitHub. But does it build? I'm not sure. Amiga part was using the cross-compiler. So we didn't have to do any code changes to build Amiga version, right? So you had PC demo running, you cross-compiled it on Amiga, and you were done.
Stupid question from myself. How difficult would it be to make it? Would the development be possible on Mac OS?
Not at all.
Not at all.
Okay, that's a bold, that's a brave statement. It shouldn't be difficult. But going back to what Hakon said, if you are a programmer, that should be fairly easy to use. We didn't spend a lot of time like polishing the UI, making it more user-friendly. If I would compare this demo tool to what we have now on PC, it's like night and day, right? But this was like a one-year project. If you want an access, hit me up. I can give you an access.
How many demos did you do using it? Rise and Shine?
Using this?
Yeah.
One.
Okay.
So, Kiero, the question from myself, how is it related to your actual tool for PC you are using now? Is it any similar in the way you are working with the assets, composition and stuff, or is it completely different?
It is completely different because this was geared toward Amiga demos. And I think I mentioned that a few times. Even if it works on PC, even if you create some visual tools, you have to think with Amiga. When you are designing it, you are working with palettes. So you are working with like very limited CPU power. So what we have now on PC is completely different. We could lift some concepts to incorporate into this one because this was just like a year project and we didn't really try to make it more flexible. But no, this is not something that you can even compare.
Thank you very much once again, Kiero. One more big clap.